Hello, my environmental detectives. You are getting this because you have completed your detective work on our second pollutant, acid rain. And so I want you to check your work on acid rain day 2. So it started by hearing an interview between a reporter and our student detective, Juan Tuño. And Juan let us know that normally rain is slightly acidic. Your answer to number 1 should be a 5.6 to a 6. And he also says that in the gray area, our rain is acidic. It's acid rain. We knew that from yesterday with the pH testing. But here's stuff we didn't know, that acid rain actually comes into two categories, chemistry categories, nitric and sulfuric acid rain. Now, when you hear nitric, you probably hear the element nitrogen in there. In sulfuric, you hear the element sulfur. So depending on the chemistry of the acid rain, scientists can actually get a pretty good idea of where this comes from. Juan goes on to say that nitric acid rain mostly comes from cars, and that's your answer to number 4 there. Nitric acid rain mostly comes from cars, and that sulfuric acid rain mostly comes from factories. So our next thing that we wondered was who was to blame for the acid rain. Would it be Don Juan Tuño or maybe a new suspect, Latoya Factory? And then Latoya Factory started talking about car drivers, so that took us back to Avery 1. So after watching that small video meeting Latoya, you should have been able to answer these 3 questions. We suspect Don Juan Tuño because of the air pollutants from the oil refinery. Those can go up, combine with water in clouds, and cause it to rain with an acidic pH. We also suspect Latoya Factory because her toy factory gives off air pollutants. And finally, we suspect Avery 1 because the exhaust pipe of her car gives off air pollutants that can cause acid rain. The deal is, though, the oil refinery and toy factory would be mostly sulfuric acid rain, while the car driving would be nitric. So it brought us now to our acid rain questions, the what do you think questions. And I hope that you did a good job on this. Let's check these back out from the acid rain files. Did you catch this? Remember how it was raining with an acidic pH 4 everywhere? If the acid rain actually falls on limestone, it neutralizes the acid. Limestone is a base. And so it becomes a normal pH. Do you remember how bee sting venom is an acid? So baking soda, which is a base, takes away the pain. It's very much the same idea. But look at this. Granite, when it rains on granite, it does not neutralize the acid. And so looking at the geology of the gray area now, do you see how the faux Mississippi, where they had a neutral pH, has limestone to neutralize the acid? But the Rafta River, the Rafta plus Lake Adasical, that's granite over there. And granite is not a base. It has no power chemically to neutralize an acid. So let's look at our first question there. You had to use the words neutralize, granite, and limestone. So this question was basically, how could it be raining with a pH of 4 everywhere, yet some waterways be a 7? And so I said it this way: some acid rain falls on limestone rock. The limestone neutralizes the acid. In the Rafta River area, the rain falls on granite. Granite does not neutralize the acid. So the interaction between the soil and what rock types are dissolved in the soil and the acid rain plays a major role in the gray area. Now, I don't know if you thought about this, but remember all those water fleas that were dying downstream of the water slide in the Faux River? Could it be acid rain and not chlorine that's killing them? Well, the answer is no. It's definitely not acid rain. Remember, the Faux River is over there by James Pond. There's limestone around that area to neutralize the acid. That waterway is okay for water fleas. It's a perfectly neutral pH. Our third question there is basically, does it always acid rain right where the air pollution is? And that's a no way. Wind can blow it further away. So when you hear a suspect saying, oh, it can't be us because the river right by us is fine, that is not good evidence. We have to remember our dominant wind, the westerly winds, will blow those air pollutants in other places. Okay, now the next thing that you should have really been thinking about is this analysis. You know how if a suspect in a real crime leaves fingerprints or DNA evidence, it can show you who did it for sure. And so it's the same thing here with this chemistry of the acid rain. Notice that by far, 88% versus 12, the acid rain in the gray area is nitric acid rain. Now we have to eliminate this electric utilities business because we do not have a coal burning power plant. So then look what jumps off at us. Cars and trucks, mostly nitric acid rain. Second to only electric utilities are factories. So this should have helped you understand who was to blame. Now, question 4, though, has to do with the eggs. Did you catch that acidic waterways don't allow the eggs to develop properly? And then going back to this, right, most of the acid rain was nitric, which points to cars as the culprit, as the guilty party for the acid rain in the gray area, and not factories. Now, my little red question here, remember at the end of this, you had to vote for someone. And I'm not going to reveal yet who's guilty or not guilty about those. I think you can make a case for a couple of them being guilty so far. But out of Don Montuno, Avery One, Cannonball that owns the water slide, and Latoya Factory, I just wanted to get you thinking like you will for the assessment of who would be the most guilty. At the end, there'll be 4 guilty and 5 not guilty. Oh yeah, we're going to be starting our next pollutant very soon. It's called sediment.